What I want to look at now is the techniques that can be used, or the first technique that can be used to solve a linear equation in one variable. Alright, now when we look at a linear equation in a single variable, that simply means we're looking at an equation that can be written as ax plus b equals c, where a and b and c are real numbers and we do not want a to be 0. If we were to let a be 0, then we would have no variable in our equation, because in this equation the only variable is the x, and the a and the b and the c again are just constants that are real numbers for this type of equation. Now we want to learn how to solve these equations. Now if we have something like 3x plus 5 equals 14, we want to learn how to solve this. Now you'll learn that when you evaluate an expression that you can put in lots of different values for x. For example, if I wanted to let x be 0, I could plug it in. I'll get 3 times 0 plus 5, which is a 0 plus 5, which is 5. But that does not equal 14. And what that means is that 0 is not a solution to our equation. So we want to get rid of that. We don't want to use 0. A solution to this equation is a value for the variable, a value that I can put into the variable and get a true statement. Now if I was to let x equal 3 then I would have 3 times a 3 plus 5, which is 9 plus 5, which is 14, and we see that 3 therefore is a solution to this equation. Now the way we solve these equations is to come up with equivalent equations from the equation that we are given. And the first way we know of, or the first way that we see to come up with an equivalent equation from a given equation, is using the addition property of equality, which says if a equals b, in other words, if you have an equality, then a plus c is always going to be equal to b plus c for any real number, again, a, b, and c being real numbers. What this is in essence saying is that whenever you have an equation, you can add basically whatever you want to the two sides of that equation, and you end up with something that is equivalent. For example, if I had x plus 8 equaling 12, if I wanted to, I could add 3 to both sides of this equation. And again, the cardinal rule is whatever you add to one side, you have to add the same thing to both sides at the same time. I would end up with x plus 11 equaling 15. Now you note that this time that really didn't get me any closer to a solution, because a solution, when you find it, will be x equaling, in other words, we want the x normally on the left side all by itself, and on the right side we want to see a constant or a numerical value. So that's what we're going to always shoot for when we're trying to solve an equation, is to get it into this form. Now let's see how this is to be done. When you go for a solution, you have to use what's known as inverse operations. And by inverse, you could think of that as meaning opposite. So if I had x plus 5 equaling 9, again, this is the form that we're trying to end up with, x equaling a constant. So you're going to look at this equation, and you're going to say, alright, the x is exactly where it should be. The x is over here on the left side as I want. But also over here on the left side we have a 5 that has been added. So to get the x by itself, we will simply subtract 5. And since we've subtracted 5 on the left, this rule says we have to subtract 5 on the right at the same time. Adding 5 and subtracting 5 cancels, and my solution turns out to be a 4. Now, on the same note, if you had an x minus 7 equaling 11, then again you look and you say, alright, the x is on the left-hand side as it should be, but there's a subtract 7 here that I don't want. Well, the opposite of subtraction is addition, so adding 7 on the left-hand side will get rid of the minus 7. Since I've added 7 on the left, I have to add a 7 on the right. The 7's again cancel, and again you're left with a solution. Now there's a number of ways though to arrange these types of problems. For example, if I had a 14 equaling an x plus 3. If you don't like the fact that the x is on the right hand side, you can simply turn this problem around into x plus 3 equals 14. You can, in other words, exchange the left hand side of an equation with the right hand side of the equation anytime you want. Of course, this is not required. It's really not even necessary. But if it looks better to you, you can certainly do it. At this point, I look at it and I say, the x is exactly where I want it. The 3 is not where I want it to be. It got here by means of addition, so I will get rid of it with subtraction. If I subtract on the left, I have to subtract on the right. So when the 3's cancel, I end up with an answer of 11. Now, there's one other way that these problems could be arranged or rearranged. Let's look at negative 12 equaling 20 plus c. Now I want to use the c on this one to show that x isn't the only variable that you'll use. There'll be plenty of variables that you encounter, a's, b's, c's, x's, etc. So we're going to use a c this time. Now if you don't like this particular arrangement, you can change it. You can rewrite this as negative 12 equals c plus 20. And still yet, if you don't like that, you can rewrite it as c plus 20 equaling negative 12. Again, our addition property is going to come into play here. No matter which one of these ways you write this problem, you're going to have to subtract 20 from both sides. Again, you're subtracting because it was added. It therefore cancels. And you're going to get a c equaling a negative 32. Now, if it bothers you at all to work with these sign numbers, just make sure you use your calculator on this step. You can just type in a negative 12 minus 20, and it'll kick right out the negative 32. And something we haven't been doing that's a good idea with these equations is checking your answer. I could come back up here with this same problem, write it down as I found it, and come over here on this side and plug in what I believe my answer to be. Do the computation, and I can at that point verify that I in fact solved that equation correctly. So with these linear equations, there's really no reason to get one wrong because they can easily be checked simply by back substituting your answer into the original problem.